Now, the last topic from the unit third, that is linked list, is application of linked list. Up till now, we study what is linked list, what is singly linked list, what is doubly linked list. Now, in this topic, we are going to study that what is the application in which area or in which mathematical area we can use the concept of linked list to successfully calculating any mathematical operation. So the linked list can be used to represent polynomials. Now we know that the polynomial is the mathematical term which consists of coefficient, exponent, and the expression. And we calculating the two expression by considering some rules of exponent to add together and store the result. In the same manner, here also we are using the term polynomial but with the help of linked list. And also we can perform the different operations by using this polynomial representation of a linked list like addition, multiplication, and so on. So in this video, we will understand what is polynomial representation and how to do the addition with the help of polynomial representation by using linked list. So let us see now how a polynomial is represented in the memory using a linked list. So in front of you there is one polynomial, that is 6x cube plus 9x square plus 7x plus 1. Every term of a polynomial can be represented as a node of the linked list. So there is one figure of 6.74 which shows the link representation of the term. Now here if you observed, we are using a linked list. In this linked list we are providing first part of the expression, that is 6x3. So that 6x cube is represented like this. 6 is the coefficient, 3 is the exponent, and this is the link from one node to another node. Now the next expression term is 9x square. So 9 is the coefficient, 2 is the exponent, 2 is the exponent, and third is the link to the next node. Now 7 is the coefficient, 1 is the exponent which is not showing anything, that is 1, and the last one is the number. So 1 and exponent, nothing, no is exponent is there, so 0 and the null. So this is the link representation of polynomial. So you can represent in the same manner any polynomial by using a linked list. I am taking only one example. You can take any example to represent the polynomial with the help of linked list. So where you can explain what is coefficient, what is exponent, and how they are linked together. So by using this pointer, they are linked together, and this is the polynomial representation. Now we are going to study the addition of two polynomial by using the linked list. For the addition, we are considering two expression in front of us, and we are having a output of this expression also. Given two polynomials numbers represented by using linked list, write a function that add this list, means add the coefficients who have same variable powers Yes, so I am explaining this how we add two polynomials. So for that there are three different rule that we have to follow whenever we add the polynomial. So first observe the first number, that is 5x square plus 4x plus 2. Third is 5x square plus 5x, and the output is 5x square plus 9x plus 7. So that should be again understand by using this PPT. So this is the representation of previous expressions that we are going to add to generate the resultant list. Now again I am going to the back slide. 5x square plus 4x plus 2. 5x square plus 4x plus 2 is add with 5x plus 5x, is add with 5x plus 5, which is add with 5x plus 5. Okay, so and we got the resultant as 5x square plus 9x plus 7, 5x plus 9x plus 7. So that is the resultant expression which is calculated by using the linked list. So now we are study that how we are add these two polynomial. So we first rule that is important to add the polynomial is the coefficient, the power, or we can say that the exponent or the power of both the coefficients should be same. Then and then only we can add the coefficient. The power of both the coefficient should be same. Then and then only we can add the coefficient of that x of that power. So here phi 2 is add with phi 1. So now this is not possible because the exponent, or we can say that the power of first expression is 2 and the power of second expression is 1. So 2 is greater than 1. So in that case what will we do? So by applying the rule 1 is that if the power of least 1 is greater than power of least 2, then add directly the least 1 expression term to the resultant list. So we are directly adding the expression term to the resultant list. Why? Because the power of least 1 term is greater than the power of least 2 expression term. So we directly add it into the resultant list. Then pointer is shifted to the second node. Then the pointer is shifted to this node to add with this node. So now the power of both the term is same. So now we are in a position to add the coefficients. Now we are in the position to add the coefficient. So we are adding the coefficient, that is 5 plus 4 is equal to 9, and the power is same, carry forward. Now again we are moving to the next term, that is again the condition is same, that power is same, and because of that we add these two coefficients also in the resultant list, and after that there is a null. So in three linked list we are providing the null. So the node structure is consist of what? The coefficient, then power, and the address of next node. So by handling these two expression, we can successfully perform the addition and create a resultant list. I am again repeating once that the power of least 1 in the expression term is greater than the power of least 2 in the expression term. Therefore, we can directly add that term into the resultant list. If there is some condition occur, in that case that the power of least 1 is less than the power of least 2, then add a least 2 directly into the resultant list. And if the power are equal, then add the coefficients. If the power are equal, then add the coefficients and generate the resultant list. So this is very simple type of addition of two polynomial using linked list. So here the term is least 1, the power of least 1 is greater than power of least 2. That's why we directly add into the resultant list. Now in the next two term the power are same, that is 1 1 and 0 0. Because of that we directly add the coefficient, that is 5 plus 4 is equal to 9 and 5 plus 2 is equal to 7. So we get the resultant list as like this. So in this manner you can directly add the polynomial by considering these three rules. Thank you.